Hi, I'd like to speak to the general flexible circuit construction types that are available in the market. First of all, I'd like you to understand that most flexible circuits are all customized to the particular application. So you see every type of shape and size and material construction that would meet and be designed to that particular customer's application. But to start with, a single-sided flexible circuit is a very common type, and this is an example of that. Basically, you have a connecting point that's going on between two connectors, and there's a dynamic flexing application or a static bending application. And in this case, you have a ZIF connector on one end and an insertion connector on the other. Another type of a single-sided flexible circuit is much more diverse in the way it's been built. Here we're connecting up 6 particular connectors on one end and a ZIF connector on the other, and each would be bending and being folded into its unique application. A double-sided circuit is the second type, and there's really 2 types of double-sided flexible circuits. The first is double-sided, but there is no printed through hole or plated through hole being done between the 2 layers of copper. And that's what we have here. We have a shield layer on one side and the conductive layers on the opposite side. Again, these are being used in an interconnect application between 2 connectors. However, the other type of double-sided flexible circuit board is a plated through-hole version, and this is where the componentry or the routing of the conductors requires multiple layers, that you can't perform all of the interconnect requirements on one layer, and they jump to the opposite side of the circuit board itself. And in this case, I'd also like to point out that this has nomenclature on the top surface, and customers should be aware for the flex circuit industry that nomenclature is typically an added cost. It isn't significant, but it isn't included in the normal pricing that you would get with rigid FR4 boards. Also for typically double-sided and single-sided, as well as any type, you can also have your flexible circuits with components mounted onto them. So here's an example of the very small surface mount components. You can have leaded components, all the same type of components that are capable of being put on rigid boards can be put on flexible circuits, including tactile domes, and this is an example of gold-plated tactile dome switches that are mounted onto this. The third type of flexible circuit is really a multi-layer, and that would just mean that there are more than 2 copper conductors in the circuit board and in the flexible circuit, and they tend to be quite complex because there's a lot of routing or there's shielding that's going on in those multiple layers. And you can go up to 16 layers, the same type of layer count that you would potentially have with rigid boards, or slightly to that level. The fourth type of flexible circuit is rigid flex, and that is where the flexible circuit is actually incorporated into the rigid layers themselves, so there's no interconnect, and the copper layers, like for this example, are in layers 3 and 4 of a 6-layer board, and the copper layers are going directly into the main body of the circuit board, and plated through hole interconnect is being made all the way through the particular rigid flex section. Now, that's not to be confused with rigidized flex. And rigidized flex is basically a single or a double-sided board that has a rigidized portion adhered to it to provide rigidity or mechanical support. In this case, the customer is looking for something specific to hold at this end, or it could be mounted underneath surface mount components or leaded components to provide reliability improvements. And a couple other variations on circuit boards then are thick copper. This is a 3-ounce copper board. You can see it's starting to lose its flexibility, but it can be formed in various shapes. That's what's shown here. As I mentioned earlier, the customization component of flex circuits, this is including alternative materials and rigidized sections throughout to meet that particular customer's unique applications. So that covers the different aspects of the general characteristics and different types of flexible circuits.